Hello everyone, welcome back to the channel. If you're just joining, guys, this module one of our complete AI machine learning course, where we are going from absolute zero all the way to advanced concepts like transformer, LLMs, with hands-on code every step of the way. Today we are starting with Numpy, and I also wanted to be very upfront with you. This is probably the single most important library you will learn in this entire course. Why? Because literally every machine learning library you will ever use, pandas, scikit-learn, pytorch, tensorflow, is built on top of numpy arrays. If you understand numpy deeply, everything else becomes 10 times easier. So let's first understand the analogy. Um, think of a Python list is like a junk drawer, and you can throw anything in there, numbers, string, other list. But because it's disorganized, finding and processing things is slow. A numpy array is like an ice cube tray. Every slot is in the same size and the same type, so the computer can process all of them at once super fast. Why NumPy exists? The first question. Why do we need NumPy? Doesn't Python already have the list? Yes, it does, but Python lists are slow for numerical computing, and here is why. Python list can hold mixed data types, integer, string, and anything, which means Python has to check the type of every single element every time you do an operation. That's an overhead. Like if you have a list with multiple data types. So what Python does when it process a single element, every element, it checks its data type. So eventually it's an overhead. On the other hand, NumPy array store data in a fixed type in contiguous memory block. Basically one continuous chunk of memory like a row of locker, all the same size, lined up next to each other. That's what make them blazing fast. Let's start with the simplest possible example before we scale up. The object of this exercise is to add one member of the list with first member of list B. So imagine we have a list one, list A and list B. We will need to add each member to another respectively. So let's start our first uh, program. We will call it as Python file. We will save it. We will say uh, 01 dash numpy dot py. Okay, so this is our first file. So in this, let's instantiate a list A. That is, we can call it 1, 2, and 3, 4, 5. So this is my list 1, and we have list 2, 6, 7, 8, 9, 10. So what I want is I want to add list 1 member 1 with list A, B member 2. So eventually what I wanted to see here is I'm just dragging the result for your reference. What I want is 7, 9, 11, 13, and 15. This is the result I want. So let's see with the simple arithmetic operation with the print statement in Python way. So I'm just concatenating the list A with list B. So let's see what happened. Let me just start the terminal. So my terminal will start. I'm just saying Python 01.numpy. So what happened? So this is not the objective that I wanted to achieve. Is the objective that I wanted to achieve is to add the element one of list A with the element B. But simple list what does is just place the list one ahead of the list A and list B ahead of each other. So this is not the target. If I wanted to do in this in Python way, so I need to use the loop. So to do this, let's just uh, I wanted to instantiate a simple list in order to do this. So this is my empty list. So now what I need to do is I need to instantiate the for loop for in for uh, this is my initial variable, and what I'm doing is I'm just taking the number, I'm just counting the number of list A member, and make the loop limited to it. And then what I'm doing is taking out the list A item 1 and adding it to list B item 2. So let's see, the let's print the result whether it's the same output I want. So you see now this is the output which I was looking for in the initial, but this is the very hefty way, like using the your for loops and in your code is very hefty way of doing things. So let's see how we can achieve this with NumPy array. So before installing the NumPy array, we need to import this library. So the best way is doing thing is to create a virtual environment before installing any library. So I'm using venv module. I already installed it. I can call it as a tuts. So this will initialize my virtual environment for my Python. Now I need to install NumPy package. Sorry, let me just source the v environment I just created, then activate. Now I need to install the NumPy. So my NumPy package is installed. Now I need to import it. Before doing anything, I need to import it. Import NumPy. So I already import NumPy. I'm gonna use this my existing list. Now Uh, in order to convert these lists into NumPy array, I need to convert them into NumPy array first. So this is the way of converting simple Python list into NumPy array. So I'm just doing that, NumPy array. So this is the way I can convert my NumPy array Python list into NumPy array. Now what I need to do is I just need to print uh, list A plus list B. So what will happen? Under the hood, NumPy array takes does the same approach which I was using in the for loop. So let's print it out. So you see, in a single line of code, I am able to achieve the output. I was using the loop and initializing the list. So much hefty work. I don't need to do that in the NumPy array. So this is one thing. The next thing is we are also claiming that NumPy is way faster than the Python list. So to prove that, I already have one list. Let me just bring it up. I already copied in my course material, which I'm going to post. So don't worry, I'm gonna post everything I have. So this is my comparison script. In this script, we will see why NumPy array is faster than the Python list. So let's print this code. I also need to import another library called time. So in this, what I'm doing is I'm just generating 1 million numbers, and I'm seeing how much time Python list will take, and also I'm doing the same with NumPy array. So let's see which one is faster. So I'm just executing. So Python list take 0.00469 second, and NumPy array takes 0.00041. That is actually a 10 times faster than, sorry, 100 times faster than Python. So this actually proves the NumPy array is way faster than Python list. This also depending on the machine. Now let's move to the next section of our course. In this section we will see how we can create NumPy arrays. So for this, I'm gonna create my another file. I'm gonna say it NumPy array.py. This is my new file. So uh, there are many ways to create NumPy arrays. So first we will see the very much basic way of doing. So I'm just importing NumPy array the way I did earlier. Okay, now I need to start a list. This will be the simple Python list. I'm gonna say it 1.2.456. So this is my Python list, and to convert this Python list into a NumPy array, I can just say NumPy array. This is the array name, and NumPy array, and the list I can pass into it. So first we will print the NumPy array, and then we will also want to see the type of print uh, type and NumPy array. So we want to see how it gonna perform. Let's see Python uh, 02. So you see uh, it convert. This is my this is my Python list. I have converted it into NumPy array. Now I print it. I also then print the type. So if you see the class is NumPy ND array. That means NumPy array is n-dimensional. Normally Python arrays are one dimensional, and you cannot traverse in other directions or dimensions. But Python array built in a way you can navigate to in any dimension. So that's why we are saying ND array, n dimension array. Okay. Uh, so let's see how we can create uh, more ways of NumPy array. So in this setup, we will create 3 by 3 matrix of all zeros. This usually used to plot area while creating charts and other matrix structure. You will use this a lot when initializing things. For example, when you are building a neural network from scratch later in this course, you will initialize the weight matrices using this function. So there are so many things number and we will be going to use with NumPy array that we use later in the course. So matrix and grids are a very important concept. So we will see how we can create the 3 by 3 grid using NumPy array. If I need to do the same thing in the Python world, that will take a lot of time and a lot of code. But with Python, sorry, with NumPy array, it's super easy. So we're gonna see an NP zeros, and I'm gonna create 3 by 3. So that means 3 by 3. That means I'm gonna create. Let's just print zeros. So let's see how it's showing. So you see, I have this is my dimension. This is my another dimension, and this is my third dimension, which is diagonal. So this is one dimensional, second dimension, and third is the diagonal dimension. So this is these grids is very useful when we were initializing the model weights, and it is very important to know that. And now this is the zeros grid. We can create the one grids as well. Another function, but if I wanted to achieve the same output with in Python way, I have to do so much code, like multiple lines of code. But in NumPy array, it's just 2 lines. So this is the benefit of having NumPy array, or sorry, NumPy. So now let's see how we can create a 2 by 4 grid of ones. This also being used while creating plots and weight matrices. So we will gonna say ones one array, and you can see np.ones is the function that actually create the grid of 2 by 4, and let's see how it seems like. So you see, this is one grid of two, but the element count of is four. So now you can say that if I need to generate the same thing with in Python fashion, so I need to do if and for loop combination I need to use. So in Python it's pretty simple. So I'm just commenting out. So next thing is diagonal zeros. Next thing is identity matrix. Why do we use it? In mathematics, an identity matrix is a special grade of number like 3 by 3, 4 by 4 box, where the diagonal from the top to left to the bottom right is made of 1, and the other numbers are zeros. Think of it like number 1 in regular math. Multiply any regular number by 1 and you will get the original number back. Similarly, if you multiply any matrix by an identity matrix, you get the original matrix back. We use numpy.i because building these matrices manually is tedious. It gives us back one line shortcut to create them, so we can use them in complex tasks like solving equations, rotating shapes, initializing algorithm. So the use is pretty much wide, but let's see how we can create in single shot. So we have identity as a variable np.i, and then we will print. So you see, 1, 2, 3, 4. This is the diagonal identity matrix. This shows up constantly in linear algebra operations, which we'll cover in module 2. Let's try arrange this is similar to range function, but it returns the array instead of Python list. Start with 0. So you can say arrange is similar to the range function, but it returns an array instead of you can say the list. So because NumPy is all about arrays, so whenever we do any operations, we will get an you can say array. So let's use the range function. Not it's actually a range function. Now, so let's see how we can do this. Let's start range array, range underscore array, and np.range arrange. Not just doing this, let's give the starting point and ending point, and we can also define the distance between each number. So what will happen is it will this range will start from 0 till 10, and in each element it gives the space of 2. So let's see how it looks like. So you see it generates an array with 0, 2, 4, 6, 8, and it stopped before the 10. So because the next value will be the 10, so it has skipped that value, and it gives the equal distance of 2 between each element. So if I need to do in Python way, it will be a very tedious task. So NumPy array is pretty much like sorting our life in easy way. So there are so many things we can do with the NumPy array. Another thing which we normally use in machine learning and while we were creating the data, line spacing. So instead of specifying the step size, you specify how many points you want, and NumPy spaces them evenly. You will use this constantly when plotting functions or generating evenly spaced tests value. This will be more useful when we will be doing testing and validation of datasets. So let's see how we can use the line space function. Line underscore space and np.line space. and we'll be seeing 0 as a starting point, 1, and give the uh, distance of 5 in each element. Let's get up this mess and let's run this. So you see it start from 0 point and give it the 5 is space of 5, and it's become the 0.25, then it's again the zero point 0.5, then it's 0.75, and then it's ended up 1. So this really helps while we were creating the test data and validating the outputs, what model weights are generating. uh, Another thing which is very useful while cleaning data. So we also have random function that helps us in generating synthetic data set, testing code, initializing weights. np.random.rand generates the floats between zeros and one, and np.random.int actually generates the random integer. Let's see how we can do this. First try random.rand to generate the floating values. Actually, but the reason we have to ask why we are learning this, because the functions we are learning is going to be helpful while we were creating machine learning data sets. So we sometime we need to generate the random values to fill the missing values in our data set. So not every data set is very clean. So while we were working with data, dealing with data sets, so we have to know how to handle the data, how to clean the data. So these functions which we are learning at the moment, that will gonna help us a lot. So random function, what it does actually, it generates floating numbers between zeros and one. So let's see how it looks like. So it generates 3 by 3 dimensional array with the random integers. It's a 3 by 3 grid, which actually this simple line does. If I need to do this in Python world, I have to write a lot of code. But with NumPy, it's pretty much simple, like single line of code, a single function. And let's see how we can use the random integer. So these are the floating number, but we also have another function called random integer array. So that actually generates a random integer. No, this not every time your autocomplete works well. So we will gonna say generate the random integer between 100 and size would be 5 by 5, or maybe we can say a smaller grid. We can say it 2 by 2. So let's see how it looks like. So you see, it generates the 2 by 2 grid, and it generates the random value, random integer in grid. So these kind of methods we can use while we were creating and preparing data set for testing and validation for, and even for modeling as well. If I say it 5 by 5, so it creates the 5 by 5 grid. So you see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it creates the 5 by 5 grid. So all these functions are very much helpful. Section 4, we will gonna, I think this video has already been very long. So let's stop this video till here. In the next video, we will gonna cover array properties and indexing, and that is more like a debugging session. Uh, but I hope you like this video, whatever we learned in this video. If you like this video, don't forget to subscribe our channel and share this video with your colleagues so they can learn a lot. Till then, thank you very much. Bye bye.